All right, so someone asked about a system that looks kind of like this drawing. For instance, they had an AEM dash. They had something like a charger and a BMS on one of the CAN ports to the dash. They had something like an inverter on another of the CAN ports, and something like an aux display that wants to display inverter info as well as info from the BMS. Now this aux display doesn't have two CAN inputs, so it can only connect to one of the CAN inputs. So what we're going to do is we're going to use the AEM dash like a bridge. Basically, it's going to receive data on its CAN2 input wires, and it's going to transmit basically a copy of that data on the dash's CAN1 output wires. Because it's not physically possible for this aux display device to connect to the inverter and also to the BMS. There's some other things on the car system that don't allow those two things to be wired to the same CAN wires. So here's how we're going to do it. We've got dash display open, right? AEM DashDesign. I guess you'd usually start in the main screens. We're going to go to the the CAN page. We're going to go and find the BMS info that we care about. Again, this was on port 2, and oh, we lucked out. It happens to be pack state of charge. That's what their dash aux display wants to see. So the things that we need to know, maybe write these down or just remember them, is we're going to need to make it the same message ID because the aux display device was programmed expecting the same IDs that the BMS broadcasts. So we can't change that on the aux display. We got to basically match it, basically pretend that the dash is the BMS and on CAN1. So this ID 0x6B0, that's important. Maybe we'll try and copy that, see if we can paste it back later. This info is important. Start is 32. So it's here, right? Starting at 32. It's 8 bits, unsigned integer. Scalar is 0.5. Byte order is Big Endian Motorola, although it's a single byte, so that's not too critical. But the rest of that info is important. We're going to basically have to rebuild this this part of the message 0x6B0. So then we're going to go over to CAN transmit. Port 1 is where we want to add it to. So we're going to create a new message down here on the little plus button. Now we're going to give this a name. I'm going to call this CAN-TX BMS copy. And we're going to broadcast it at a rate of something, let's say 10 Hertz. This ID number, we have to match that. So I'm going to try to paste the one I copied before. Oh, good, and it does paste, so that made things a little bit easy. It's already got the same ID. This S here means that it's a standard address length. Extended would be if there were more bits in this ID. Length 8, that means we've got 8 bytes in this message. So that's all good. We do need to go here and match the channel name. So let's go back to our receive to remember. The name of this was pack_SOC. So we're going to find that. We're going to find that pack SOC, and it's bits 32 through 39. So here we're going to add the channel pack_SOC. Will let me type PACK. Good. Pack_SOC%. That's what we want to broadcast. The type, we're going to have to change that. The position, we definitely have to change that as well. Now I think this only does positions in terms of bytes. So let's try position 1, and that did move it to byte 1. Position 2 moves it to byte 2, which starts at bit 16. Position 3, position 4, that's the one we want because it starts at bit 32. Scalar, I do remember we need to change that. That was 0.5. Offset, we're not going to change that. Offset would be if you needed to to move it here. This type unsigned int 8, let's go double check that. Type unsigned integer, so that's good. Length was 8. Okay, that should be everything to make this one match. So on ID 06B0, it's going to broadcast as byte 4 pack SOC. Now we could also broadcast these other channels as well. Just as an example of how to do that, let's see if we can broadcast pack INST voltage, just in case the aux device wants to see that. So pack INST voltage on 06B0. It's unsigned integer. It is 16 bits, so that's 2 bytes. It is 0.1 scalar. Let's see if we can do that. Pack INST voltage. So in here, we're going to add another signal. Type pack IN. I gotta search. Pack INST voltage. And this one, can I simply type till it's unsigned 16 big endian. Now the position here is wrong. I need to go change that position because it should be up here. So if we back this down from 5, let's try 1 and see where that gets us. I think 2 is probably what we want. So it starts at bit 24 and goes back through bit 23. Go back here, 24. Good. Unsigned integer 16. That scalar is 0.1. That's important. So let's go back, make sure that our scalar matches. 0.1. Good. So that should do it. This would now be a copy on the CAN1 port that is basically relaying, right? We're acting like a bridge so that the dash is going to receive the info on CAN2, and we saw that over here. It's going to receive it on CAN2. It's going to give it a signal name, right? This is all defined by the DVC file. And then we're going to take that info that we received, the calculated signal pack SOC, we're going to transmit that out. And yeah, that should do it. So I hope that helps. If you've got questions, maybe I'll toss an email address on this video so if people can ask questions, or just post them in the YouTube thing. I'll see them eventually maybe. Alright, thank you for watching. Bye.